everyone. Today we are going to do a practical in which we will study the reactions of bases. You know that bases are oxides and hydroxides of metals, and we have to see their solubilities. If a base is soluble in water, then it becomes an alkali. So I am given 4 bases. One is barium hydroxide, the other is calcium hydroxide, then ammonium chloride and sodium hydroxide and copper to oxide. Now ammonium chloride is a salt of ammonia, so that cannot be taken as a base. So we have 4 bases, copper oxide, sodium hydroxide, calcium hydroxide and barium hydroxide. And in this, calcium hydroxide and barium hydroxide is from group 2 metals, and sodium hydroxide is in group 1, and copper to oxide is in the transition metal series. So you have 4 metal oxide and hydroxides there. So I am taking sodium hydroxide pellets into the test tube and adding water. Bung the tube and shake it well to see the solubility of sodium hydroxide. The test tube is becoming warm as the sodium hydroxide is dissolving in the water. Okay, so you can see that the sodium hydroxide has completely dissolved and the solution formed is an alkali. Take the pH and you can see that it is purple, so it is 12. pH is 12 for sodium hydroxide. Red litmus turns blue, blue litmus remains blue for sodium hydroxide. The next, we will carry out a neutralization reaction by taking 2 mole per dm cube of hydrochloric acid in a boiling tube. So two centimeter cube of the dilute hydrochloric acid, and to this I am going to add a few pellets of sodium hydroxide and observe what happens. So again you can feel the test tube getting hot and the sodium hydroxide is reacting. You can see the reaction taking place. There's a slight discoloration to the mixture. I'm going to heat it and see further if there is any reaction taking place, but at this point the test tube has become really hot. It is quite warm. So just see whether the sodium hydroxide can completely react with the acid. Okay, so you can see some sort of fumes being given out, definitely fumes of water vapor, and the sodium hydroxide has dissolved or completely reacted with the acid. Okay, so the water vapor is given out, and definitely the reaction between sodium hydroxide and hydrochloric acid will not give any significant change in the solution, but we know that it will react, giving out the water vapor which is coming out, and sodium chloride will be left behind. The next, we will take a spatula or quarter spatula of ammonium chloride. So ammonium chloride is taken in the boiling tube, and to this I am going to add a few pellets of the sodium hydroxide. And then I am going to heat the mixture and observe what happens. This is a moistened red litmus paper which I will be showing to the mouth of the test tube, just to see if there is any gas being given out, what will happen. Okay, so you can see that the red litmus is turning blue and a gas is being given out, which is turning the red litmus blue. So this is a clear indication. You can smell the gas and you can see that it is having a pungent smell. The gas is having a pungent smell. It has turned the red litmus blue, so the gas is definitely ammonia gas. The next base we will be testing is calcium hydroxide. So calcium hydroxide is a white powder. I take a quarter of a spatula in a test tube and try to dissolve in water and see what happens. So there is a cloudy solution, and the soluble part will form a clear solution after some time. Maybe it will be a little cloudy, but since calcium hydroxide is not completely soluble in water, the insoluble part of the calcium hydroxide will settle down, and the calcium hydroxide which dissolved in water will form the upper layer. So I leave it to come back to it later. So now I can determine, so you can see the separation happening. I will take a little of the solution and then add it to the litmus paper, red litmus paper, see what happens. It's changing to blue, so indicating that it is not so obvious, but it is still changing to blue. So it is an alkali formed, but it may not be a strong alkali. The pH paper is turning purple, and of course the blue litmus will not give significant any color change. So you can compare the pH. For the pH paper, it is working out to be 13. Okay. Then we take a little of the calcium hydroxide and add it to the boiling tube in a 2 ml dilute hydrochloric acid, which is 2 molar concentration. So bubbles of, there is a slight bubbling, but there is no evolution of any gas. It's just that the calcium hydroxide is dissolving in the acid, and then on slight heating, you can hear a crackling sound as it is getting warm, and you can see the vapors of water being given out. Now, calcium hydroxide is not completely reacting. There is the settling down of the unreacted solid, which may be excess of calcium hydroxide, which has not reacted. To the next boiling tube, I will add ammonium chloride, a spatula measure, and take a spatula measure of calcium hydroxide and heat it gently. And if there is any gas being evolved, I am going to test it with a red litmus paper. So you can see the white fumes of the gas being evolved, and again the litmus paper is turning blue, and this gas given out has a pungent smell, so it is ammonia gas. The white fumes, yeah, you can see the sublimation also happening. Ammonium chloride that has also sublimed, and some has reacted with the base to give the ammonia gas. The next base of our study is barium hydroxide. So I'm going to take barium hydroxide in a test tube and try to dissolve and water and see whether it is soluble, completely soluble, or less soluble. So you can see that it is not completely soluble, it is partially soluble, and there is some residue at the bottom. Whereas in the case of calcium, calcium hydroxide, this is the solution obtained. So barium hydroxide is partially soluble and calcium hydroxide is also partially soluble. But if you compare the solubility, barium hydroxide is more soluble than calcium hydroxide. So I'm going to take a few drops of barium hydroxide and test its basicity on the litmus paper. So you can see that the litmus paper is turning blue, red litmus is turning blue, but it is a slow reaction. Whereas if you see the pH paper, it is having a green color. So it is 8 is the pH. So it is a weak base. Then I heated barium hydroxide. I will take 2 ml of the acid and then add the barium hydroxide. as a reaction, the reaction is quite vigorous, and you can see that the barium hydroxide is immediately reacting with the acid. So I'll take some more and add, and you can see the bubbles of gas being formed. Brisk effervescence is being taken place, and on heating, let's observe what happens. So you can see the vapors on the sides of the test tube. So definitely it is water getting vaporized, and we get a solution mixture there which is cloudy. So barium hydroxide has reacted with HCl, giving barium chloride and water. So a neutralization reaction has happened. Into the next, take ammonium chloride, 1 spatula measure, and I will be adding barium hydroxide. And gently heating the mixture. Any gas being evolved is tested with a red litmus paper. So again you can see the red litmus paper is turning blue. A gas with a pungent smell is given out, and you have the fumes being formed, white fumes. So the last base that we will be investigating is copper-2 oxide, which is a black solid, and copper metal is in the transition period in the periodic table. So I take a spatula, a small spatula of the copper oxide in a test tube, and add water to check its solubility, and I get a black solution. Even on shaking, you can see that you get a black solution there, but it's actually not exactly dissolved. Okay, copper oxide is not soluble in water. It just mixes because it's just a fine powder, and you get a black solution there. And if you leave this for some time, the copper oxide particles will settle down. So that's what I will leave it. And you can see that it is already settling slowly. So I will take a few drops of copper oxide that is being formed to test for its alkalinity. So add it to the red litmus paper, add it to the pH paper, and a few drops to the blue litmus paper. So you can see that the red litmus paper is turning blue, not that blue, but still it is turning blue. The pH paper is showing a very light green color. So it must be in the range of 7 to 8. And let's dissolve copper oxide in acid and check for its reaction. So I'm taking dilute hydrochloric acid again. And add copper oxide, a quarter spatula. No obvious reaction at this time. It's just like dissolving it in the water, you can see a dark black color. So let's heat and see whether a reaction is happening. Vapors of water formed. Yeah, and you can see that the solution has become blue. On leaving, the black particles will settle and you will get a blue solution, but it has turned blue. So the blue substance formed is actually copper chloride. So you can clearly see that the copper oxide that we had taken has reacted with hydrochloric acid to form a blue solution, and vapors of water have escaped as well. Test tube, I will add ammonium chloride and copper oxide. And heat the mixture. You can see the white fumes being formed. And the gas is turning the red litmus paper blue. So this experiment gives you an investigative study into the properties of bases, and you can also differentiate between a strong base and a weak base. You can also look for which of the bases are alkalis and see whether it is a strong alkali or a weak alkali.